the notes for integrated 2, 3.2.5. We're going to do some applications of the tangent ratio. A couple of things to note is that we have this whole angle of elevation and angle of depression. Ultimately, here's the idea. So let's say we take a single person. So here's my little person. From their eyes, we look straight out. Now this is called their line of sight, when they look straight ahead. And you'll see this in the other pictures on this page as well. So looking straight ahead is a 0-degree angle. Now from here, we want to think about, well, what happens if our person looks up? So from their eyes looking up. And we would say that this angle looking up, this is called an angle of elevation. Then, if you go back to eye height, or line of sight, not looking up or down, just straight ahead, and looking down from there, that is called an angle of depression. Which you can see in the few pictures that I have on this page. Okay, let's take a look at some examples. So we've got this scenario with Joseph, and he wants to know if he can climb up to the torch for the Statue of Liberty without getting a nosebleed. So we need to do some calculations for him. Well, you'll notice that we do have this whole idea of eye height. So I have my little tiny picture in purple of Joseph off to the side. Would say that his eye height is 5 feet above the ground. So we do have this drop down idea below the red. However, that's not necessarily going to give us a triangle. So we'll pull that out, and we're only going to take a look at the red triangle itself. From here, we want to identify our sides. So what is it that we have based off of the information that's given to us? So if we start at the 82 degrees, we go opposite that. That's where the X is located. So I believe X is going to be our opposite side. Starting back at the 82, and we go right next to it, not the hypotenuse though, this is going to be our adjacent side. Okay, so let's go ahead and set up our tangent ratio. So I know tangent of my angle, 82 degrees, is equal to opposite, that's X from the picture, and adjacent, which is the 42 feet. Let's go ahead and solve for X. So put a 1 under that, and we're going to cross multiply. So 42 times tangent of 82, and then 1 times X is just X. Okay, X is isolated by itself now. So have your scientific calculator in front of you, either your own or the one that I have linked to our class. And we'll go ahead and multiply those two together. Okay, so that's going to give me 298.8455. That's the approximation for X. So let's actually turn that into an approximate. So on first glance, we would say, yeah, sure, Joseph, go right ahead. You won't get a nosebleed, but we need to consider the fact that he still has that additional 5 feet. So we need to add 5 because of his eye height. Once we do that, I think we just went right past the 300. So this is going to be 303.845 feet. So that's going to be from the ground to the torch. So I guess what I would be saying to Joseph is you can climb, but you're probably going to get a nosebleed. So since the height is greater than 300, Joseph should expect a nosebleed. Okay, let's Let's take a look at another one. All right, so the picture isn't given to us this time. We're going to have to draw it. All right, Leon is standing 60 feet from a telephone pole. All right, well, let's draw the telephone pole. Okay, so let's say we've got the telephone pole here. So we'll call this, the whole thing is going to be the pole. And he is standing 60 feet from this. All right. So 60 feet along the ground. He's over there somewhere. And I know that distance is 60. So let's put that in. All right, moving on. As he looks up, okay, this is an angle of elevation. A red-tailed hawk lands on the top of the pole. Leon's angle of sight up to the bird is 22 degrees. His eyes are 5.2 feet above the ground. Okay, we have to draw Leon in now. So let's go ahead and draw him in down here at the end. So this is going to be Leon, but I'm only drawing in Leon up to his eyes. And then from here, I think I'm going to draw in his line of sight. So from the top of that, we're going to go straight out. So not looking up or down. And typically what you'll see with line of sight is they're kind of drawn in dashed lines. They may not necessarily be part of the picture itself. So let's put some information in here. So I know that Leon's eyes are 5.2 feet above the ground. So we would say, and then we have that angle of elevation. All right, so from his eyes to the top of the pole. And then I know that angle of elevation right there is going to be 22 degrees. Okay. All right, well, let's be careful here because the telephone pole includes the 5.2 feet. So I am going to call just this little portion that's for the triangle, I'm going to call that X, stopping right at the line of sight. All right, I think we can actually solve for this now. So I know opposite the 22 is X. Right, so that's the opposite side. And I know right next to it, well, it doesn't look like there's a measurement there, but there is, because the 60 feet can come right up to that length as well. And so this is going to be our adjacent side. All right, let's go ahead and set up our tangent ratio. So we'll have tangent of the angle, which was 22, opposite, which was X, and the adjacent, which is 60. All right, let's go ahead and solve. So put a 1 under this, and let's cross multiply. So 60 times tangent of 22 is equal to X. Go ahead and type this in. And it looks like we get 24.2415 approximately. Okay, but that's not the height of the pole. The pole has to come all the way to the ground. So to find the height of the pole, we're going to take X, which we had found, and then we have to come back down all the way with that additional 5.2 from his eyes. Okay, so basically, we're going to go back over there and we're going to add 5.2. So the pole is approximately 29.4415 feet.